Okay, so on the second page here, we get another one of these graphing ones. So remember, the positive to negative switches are the x-intercepts. So at -3 and 1, this graph has to have x-intercepts. And then the decreasing to increasing is where the turning points are located. So at -1, this graph has to turn. And we know it's positive at negative infinity. So out here at negative infinity, the graph has to be positive. So it's got to start up, comes down, loops through. These ones here, honestly, more just like kind of conceptual reading graph type questions, but they're asking you for both people, and they're following this equation. So they're going hiking, and it shows their elevation over time. And it says, when will he be at 17 below sea level? So technically, this is -17. Sort of tricky that you got to read that part of it. If you graph this, you get a graph that looks something like this. And you see that, he starts going down, and then he goes up, then he goes down again. Well, -17 happens around here on this graph, whether you do it in your calculator, whether you do it on Desmos, whatever. And that happens between 8 and 9. So I just said between 8 and 9. You can actually get the actual value by clicking on there or finding the number, but I'm just kind of giving the general answer here of when that happens. And same thing here for Nadia, same deal, different equation, asking when does she get to -16 meters below, or below sea level there. So she goes down, she goes up, she comes back down. This is that spot. Hers happens between 6 and 7. So that's a reading the graph, finding your point on the graph to answer the question. Subtraction problem. Make sure you distribute this negative to all the terms afterwards, and then combine any like ones. So, like your x squared terms combine, your two xy terms combine, your two y terms combine to get you to there. So keep it in standard form, and then combine any like terms. Another subtraction one. Negative gets distributed, and then combine your like terms. So your x squared, only one, so it goes there. Your xy terms, combine those like terms. Your two y terms, combine those, and then your just constant here, +4, goes on at the end. The last two are volume, which is like a geometry kind of crossover question. It's really just making sure you can do the multiplication here. So to find volume, you do like length times width times height, or length times base times height, however you want to call it. We multiply these three values together to get the volume. But the problem is really just about, do you remember how to multiply three quantities together? So can you take this quantity, distribute it to those, simplify it, and then take it and multiply it by the third quantity, the x? So take a look at the steps there, the distributive property. The other part of this question, also not as important of a thing, talks about what's the maximum volume. Well, if you graph this, you see it looks like this. It goes up towards infinity. So as you make the length, width, and height longer, it goes up to maximum volume. So the volume is actually at infinity. That's the highest it can go. So sort of a weird question. Honestly, not a super important one in this regard. The important part here is, do you remember how to do this multiplication? Can you get from here to here? Okay, and same thing on this one. Actually, really, basically exactly the same, just different numbers. So I distributed these two parts together, combined my like terms, and then I distributed the 3x to each of those. So same concept with the max volume, which again isn't a big deal in terms of this quiz. So, all right, good luck on it.